Algorithms can be beautiful. I remember since I was a kid that mazes just always looked like magic to me. And when I started to learn to code and I discovered that you can make mazes with code, and it would be a new and different maze each time, my mind was so blown I decided to learn to code professionally, and it impacted me until today. So I want to show you the magic of generating mazes with code. I want to explain the algorithms simply, and I want to show you how simple yet beautiful it all is. So what even is a maze? Like this is not a maze. So to get it closer to being a maze, we can add walls. But this is still not perfect. We can remove the loops to make it even better. But this is still not fun because there are many places in the maze where you would get stuck. You can't reach the rest of the maze, so we need to make sure every point is reachable from every other point. Now this is a perfect maze. You can reach from any point to any other point in the maze, but there is only one way to get there. So now you can probably appreciate that making a maze is a very non-trivial task. It's pretty hard. And writing an algorithm that makes a perfect maze and a new one each time should be a hard thing. Now I want to show you two very simple algorithms that, with very simple rules, can generate mazes that are guaranteed to be perfect. So the first one is DFS, or Depth First Search, and this is actually my favorite one, and it's the first one I learned. Okay, let's see how Depth First Search work. So we can choose a square, it's gonna be the yellow square. We can start from anywhere in this grid, and we'll check our neighbors. If we have a neighbor that is only surrounded by white squares, we can go there. But if it's touching a black square or an edge, we can't go there. Until we get to a point where all of the squares around us are blocked. And what the algorithm does when it gets to this point is it's starting to backtrack. It's starting going back until it finds a new green square. We can see that we can branch off here, and now we can't go forward because it would connect us back to the path, but we can go up or down. You can see that we colored the places that we backtracked from in a different color, like in a solid black instead of a gray. And that's to just know to not backtrack again into this place because we already checked it and there is nothing there. And by just doing that, we will create a perfect maze because we are branching off and everything is connected, and we are never creating loops because we never connect back to the path. So yeah, we just keep on going. And this algorithm have a very nice thing where when we finish, we can see that we are going slowly back to the start. And every time we know we completed the maze, if we went back to the square in the beginning, and the maze is completed. Now at the end of this video I'm going to generate some really big mazes, and I'll also try to miserably solve them. Okay, let's move on to the next algorithm. So this algorithm is so simple, it kind of describes itself. It's a fractal maze, which means we just duplicate what we have 4 times and then we'll create 3 openings. Then we just repeat the process again and again, and we'll get a perfect maze of any size. So this maze is definitely perfect, but it's definitely not random, because there is no randomness in this algorithm. And the bigger the maze, we can start to see the patterns the maze follows. Although those patterns are infinitely complicated, there are patterns. If we want to introduce some randomness, we can randomize the place where we punch the holes after duplicating all 4. Like this step, we can choose to punch different 3 holes. And here again, we can choose different holes to punch. I don't know about you, but for me the combination of this symmetry and randomness is very beautiful. Like I can imagine this kind of pattern on tiles and just, yeah, it's beautiful. Okay, so let's generate some big mazes and I'll try to solve them. Okay, so I have the maze loaded on my iPad and I'm going to try to solve it now. Yeah, like wish me luck. I'm going to start in this point, like in the starting point, and we are going to finish in this point. Let's put it like in green. And the path is going to be blue. Okay, I'm actually very confident. I already got like halfway, but it might be deceiving. I did not think I'm gonna be able to do it, but I think I'm almost at the end. Oh my god, I got it. I think if I'll be like a first-person player walking here, it will be impossible. But like this, when I see everything from above, it's much easier. This is such a convoluted path, and I think I got really lucky with this maze that it's particularly easy. The more I grew older and the more professional I got, I think also the less magic I noticed in the stuff I do. And for me, coming back to maze generation, just for making this video, really reminded me that. And yeah, and I'm going to remind you also that, you know, it's so easy to forget the magic that you saw in the world when you started, when you grow older. So yeah, just find those things and do them. And if you are in the process of learning to code, I think it's a great exercise to try and write a maze generation algorithm. So yeah, try it. I will wrap up the video here, and if you enjoyed it, I have many more interesting videos like this one where I take memes and I combine them to find the average meme of all using AI. And yeah, you are more than welcome to click on my channel and see what other videos I got there. And if you like stuff that I do, please consider subscribing. And if you like this video specifically, like it so more people can see it. And I'm gonna see you in the next one. Bye bye.